right, so chapter 4, just to fair warn you, the amount of actual equations and mathematical computation that you will be doing in chapter 4 is very minimal. Some of you are going to love that, and some of you, it might not be your favorite. There's going to be a lot of definitions. There's going to be a lot of terminology. And it all focuses on, in chapter 4, we're going to talk about sampling. We're going to talk about observational studies. We're going to talk about experiments and experimental designs and everything that goes with them. Sometimes you might think this might be a psychology or sociology class with all the terms that we're going to be talking about. Because a lot of the terms and terminology are things that are covered in those courses. Many, if you decide to become or major in psychology or sociology or some of your other social sciences, even economics, some of them require you to actually take a statistics course. Okay? Especially with psychology, if you're doing a lot of different observational studies. They want you to understand the mathematics and the terminology behind all of those types of studies and experiments. Chapter 4 is the basic and introduction to that. So you'll see today that we'll be doing very little math. We'll be playing around with a little bit of math today. Not much, okay? But a lot of terms, a lot of definitions, defining things, and there'll be a lot of writing. So some of your questions you'll have to write 3 or 4 sentences. So it does involve a lot more writing to it. So if you've heard the rumors about statistics being, wow, you do a lot of writing in the course, you're going to start to see a little bit of that in this chapter. So, anyway, today we're going to talk about sampling, and we're going to talk about, surveys. I had a nickel for every time I did that. So let me get it back to the pen mode. So, first of all, we start off with 2 definitions. We start off with population, and we start off with the definition of a sample. Okay? In statistics, when we talk about a population, basically we're going to do a study, or a statistical study, where we look at the entire group of individuals which we want to try to get some information about. Your population, lots of times people, when they think of populations, they're thinking like the populations of countries, the United States, okay, or China, or looking at England. But your population doesn't have to be necessarily that big. We could have the population be students in Mr. Bartz's 4th-hour class. Okay? We have currently 30 of you here today. Okay? So our population could be a total of 30 students. It could be that small of a population. Okay? But it can get a little bit bigger and bigger. We could talk about seniors here at Hopkins High School as our population. So now we're talking about 600 students. We can talk about all students at Hopkins High School. Now we're getting about 2,000. We can keep on getting bigger in the district of Hopkins. So now we're talking about probably close to 7,000 to 8,000 students. And I can just keep on getting bigger and bigger and bigger. Okay? So now, from this population, we collect a sample. Again, it's a part of the population where we actually collect information. So we actually gather and get information about that population. So from our class, I might be looking at, all right, let's take a look at the gender and the age and what you ate for lunch. Might be some of the information I might be gathering. Okay? But I'm not going to necessarily gather it on the entire population. I might only ask 5 of you in some way, shape, or form. How I determine that? Well, we'll talk about some sampling techniques. Now, based off those smaller samples, we're going to draw a conclusion about what they responded to and make a conclusion about the population. Now, sometimes when you sample, you get it right. Sometimes you don't. Okay? But first of all, it's so important to be able to identify what's your population and what's your sample. So that's what we're doing in these first couple examples here. So again, it says identify the population and the sample of each of the following settings. So in the first one here, it says the student government at a high school surveys 100 of the students at a school to get their opinions about a change in the bell schedule. So when you're describing the population and sample, you want to be specific. You don't want to be lazy and just say, oh, it's students. Okay? Because yeah, it is students, but we need to be specific. Okay? So our population represents all students at this high school So we're looking at specifically all students, I hate it when I forget the S, at this particular high school. No. Now we're going to look at the sample. They surveyed 100 students, okay, and got their opinions about the change in the bell system or schedule. So our sample is the 100 students who gave their opinion on the bell schedule. You guys like our bell schedule here?
No, we need to turn the bell noise off.
Fast days. We need a good 20 minutes.
I'm in all favor of extending passing time to 10 minutes.
Why is that?
Because I would love for our school to start at 7:45 and end at 2:35 or 2:40 or whatever time it would take, so that all of our classes start and end on a 5 or a 0.
Yeah, I feel that.
That's okay, simple if people are.
I have actually proposed and written up the entire schedule and given it to the administration. I've only done it once. I figure I gotta do it about 5 times before.
Just do it again.
Do it again right now.
They didn't really say no, they didn't really respond.
Fight the man.
Get our stimmy. Let's fight how we do.
Back in the
Fight the
day,
man.
we did.
How's that fighting the man?
Alright, so now, number 2 is a great example because so many of us want to think the population has to be people, but it doesn't actually have to be that way. And number 2 is a great example of it. It says the quality control manager at a bottling company selects a sample of 10 cans from the production line every hour to see whether the volume of the soda is within acceptable limits. So what's our population here? Let's be even more specific than just cans.
Cans from production line per hour.
Okay, so all cans produced on this assembly line.
Per hour.
Well, it's not even just per hour. We're talking about all the cans that are
But it's
produced.
taking a sample per hour.
But it's doing it every hour, not so.
Yeah, it is doing it every hour.
Right. That's the sample. That's not the population. The population would be every single can that's produced on this assembly line. Yes. Right? What did I forget to do? I am recording it. It's been going for a long time. Okay?
Hi, Dad.
So now our sample, okay, is the 10 cans selected each and every hour. This is typically done on the assembly line. Whatever products they're making, they will take samples at a periodic time interval and measure something about the product. Like in this case, they're measuring the volume of the soda can. I'm sure they're trying to do that by a weight of some kind to figure that out. I don't think they're going to open up the can, pour it out to measure up the volume, and then try to pour it back in and seal it up. Right? That kind of defeats the purpose of it. Okay. All right, so now one of the things that we like to do is collect sample surveys. Now, in sample surveys, we're going to select a sample from the population that we desire information about. We're going to use that information to draw conclusions about the population. That's why it's so important to specify exactly what your population is and also the variables you're measuring. So like in the previous example, we're talking about all the cans that were produced on this particular assembly line. We were taking 10 cans every hour. We were measuring the volume. That was the variable that we were actually taking a look at. So we want to then take those samples and make judgments, okay, about the entire population. Okay? So companies will do this. They will take a sample of their product to make sure that everything is okay. So I tend to use this as a common example, but company makes potato chips. They will take a sample every 15 minutes and they will measure the salt content. Because if it has too much salt, okay, people are going to call and complain and want their money back. If they're not salty enough, same reasoning. So they want to make sure that the salt content levels are within a specific interval. Okay? So they make their judgment based off of that sample. They'll sample it and say, all right, that last batch of potato chips, those last hours should be good to go based on salt content. They'll do the same thing on the chips and measure their thickness of the chip. Because if the chip is too thin, it's going to break too much in the bag, and then you open up your bag of chips and all you got is a bunch of crumbled potato chips. If it's too thick, when it cooks in the oil, it's going to be probably too chewy. Okay? So sampling, very important. Now, when we do sampling, whether it's on objects or if it's about people, there are some great sampling techniques and there's not so great sampling techniques. Unfortunately, we experience a lot of the bad sampling techniques. Okay? So let's talk about a few of these real quick. Convenience sample, or convenience sampling. Convenience sampling is simply where you target the easiest individuals to reach. Okay? When I think of a convenience sample, I think of sometimes what is done here at school. Sometimes you might be asked to do a survey for a class about the student population. Okay? Students will just grab 5 or 6 of their friends because they know them, they can ask the questions real quick and be done with it. Okay? It's easy, convenient. But is that going to be a good representation of the school population?
No.
Probably not. How many of you have ever experienced going out to a mall, whether it's Ridgedale or Eden Prairie or Mall of America, and somebody's there with a clipboard and they're asking you, hey, can I ask you a couple questions? Can I ask you a couple questions? Have you ever had that happen before?
No.
Okay. I at least got 1 or 2 people that have actually experienced that. That is, in essence, a convenience sample. Okay? They're trying to, get responses quickly and fast. The best part of what's nice about the convenience sampling is it's fast, but not always the best. Here's the second, which many people feel at times is a good way to sample, but can definitely lead to a lot of bias. And that is called a voluntary response sample. This is where you ask people to either call in, or companies mail out a survey to you and ask you to mail it back in. Okay? Or, as it says up there, internet polls. I think of the news. Okay? Once in a while the news will pose a question. I think Channel 5 was notorious for doing this for a while, but they would pose a question to its viewing audience saying, hey, call this number if you think yes, and call this number if you think no. We want to know your opinion. Okay? When people volunteer their responses, okay, it tends to be biased because people who are going to actually take the time to do it feel strongly about the issue in one direction or the other. We'll see some examples of this more today. I know the example here, I said voters responding to the hit TV show Dancing with the Stars. I mean, that's kind of biased because people are going to vote for not necessarily the dance quality, but they're going to vote for the person that they might like the most. Okay? Plus you have to actually call in. Okay? And you won't get necessarily the person who might be doing the best, but who's getting the most votes, who's the most popular. Okay? So now, both these samples tend to lead to some sort of bias. And when we talk about bias, we're talking about a sample that will consistently either overestimate or underestimate the true value that you're looking for. Okay? So bias systematically causes or goes in the favor of a certain outcome, whether it's intentional or unintentional. And later on we'll talk more about bias, how it's not just in sampling where it can actually occur. Okay? Alright, let's flip to the next page. Just like that. We're already halfway done with today's notes.
No way.
Yeah.
What?
I know. Alright, so one might ask, what are some good sampling techniques? What are some things that we can do to at least make collecting our sample a little bit better? Okay? One of the techniques that we're going to at least talk about today, and this is the only one we're going to talk about today, is called a simple random sample. Here is another acronym for you. SRS. You will see your textbook use this SRS all the time. You will hear me talk about it quite a bit later on in this course now, since it's being introduced to you. You will hear me refer to it, well, did you take an SRS? You'll be like, what? And hopefully you'll know that I'm talking about a simple random sample. Okay? So basically in a simple random sample, the biggest piece is all the individuals have to have an equal chance of being selected. So for instance, in this class, 30 of you, one of the things I could do is take, for instance, a note card and put your name on the note card, or like I do with the popsicle sticks. Your names are on all those popsicle sticks. I could mix them up and select 3 names at random. Each of you had an equally likely chance of being selected. Hopefully that I have all your names on those popsicle sticks. Okay? So putting names in a hat, drawing one at a time. Okay? Now, the other thing that's very important about a simple random sample, because we'll talk about some more in-depth random sampling, but a simple random sample has to make sure that every possible sample collected has an equal chance of being selected. So to tell you a little bit about this and how it can be deceiving. So say for instance in this class, which I don't think it is the case, but if I have a class of 30 students and I have 15 boys and 15 girls in the class, okay? And I decide to collect a simple random sample of 2 students, 1 boy and 1 girl. Does each student have an equally likely chance of being selected?
Yeah.
It's what's that probability?
50-50.
Not 50-50,
100.
1 out of,
30.
not 30,
15.
but 15. Okay?
Damn.
4 times the charm.
Yeah, you know.
We got it. Okay? So each student has a 1 in 15 chance of being selected. So the probability is the same for each and every student. However, since I'm taking a simple random sample of 2 students and I decide to select 1 boy and 1 girl, is every possibility of 2 students possible?
No.
Why?
Because you can only do 1 boy and 1 girl.
Okay, what's being left out?
Same gender twice.
Okay, the same gender twice. So having 2 boys or having 2 girls has been left out of the sample. They couldn't even be a possibility. So since they can't even be a possibility, technically it's not a simple random sample. Okay? Not each and every group of 2 students had an equally likely chance of being selected. Some groups were completely left out. Alright, so now, how do we in statistics tend to do a simple random sample? This is where we finally get a little mathy today. Right? So how we like to do random samples in statistics is by using what we call a table of random digits. In your textbook, this is table D.
Where did B and C go?
We'll come back to B and C. They're there. They're just different distributions. Table A was the normal distribution in chapter 2.
That's the Z-score one.
Z-scores. Now, since I have a minute, let me do this. If I go to, yes, I want to stay logged in. I don't want campus instruction. Where'd it go? I don't want my email.
Uh-oh.
Bummer. So, I had it bookmarked and it is gone. That's okay. I am going to go to your online textbook. I don't want the AP Central, I want your textbook. I want the exam. Yes, I'm still recording and logged in, I hope. Hey, there we go. Now, here's the front page of when you go to your online textbook. So in your homework tonight, if you have to use the random number table, what you should do is log on to your online textbook, and if you look down here in this column on the left, Table A, Table B, Table C, Table D. If I click on Table D, it's actually going to download a PDF right on to your Chromebook. So it'll be down here in the bottom corner for you. It's actually going to give you a table of random digits. So what this table of random digits is, it's actually 2,000 random digits right here.
That's a lot of digits.
It's a lot of digits, so you'll never run out, at least for this course. But to make problems at least consistent when we do the problems in class, sometimes we'll have you all start at the same place so we get some consistency with answers. So that's why they have this line down here, line 101 all the way down to line 150. Because I might say in a problem, start at this particular line to determine who gets selected. Okay? So we're going to show you how to use this here today. So, in our steps, my apologies as I go back to our display here. Your table of random digits, as you saw, was a bunch of numbers, in groups of 5 from 0 to 9. Okay? Each of those digits were equally likely to be selected. what was really nice is someone actually drew the numbers out for us and has done all the legwork for us, so we don't have to do that part. So, if you're going to use this random number table to determine a simple random sample, you have a couple steps you need to do. The first thing you need to do is you need to label. You need to give each member of the population a numerical label, and this is the most important part, of the same length. So if I have a random sample of 20 people, or 40 people, or even 70 people, okay, I want to give each person or object, whatever I'm talking about, the same number of digit lengths. Okay? So when I label them, I will want to say each person or each object gets a number between 0, 1 and whatever my ending number is. Not 1 to 1 to 70 or 1 to 1,000. Because 1 is a 1-digit number. 1,000 is a 4-digit number. They all have to be the same size. So if you're going to use a 4-digit number, you would say 0001 to 1,000. Because they all have to be, again, the same size. Okay? Now, the second part is, then you have to explain how you're using and reading the table. So, you actually show your work. You'll write a couple sentences describing how you're picking them and actually do it.
When you said that, like, the 4-digit number 1 to 1,000, were you talking about scaling the graph? Or
No, you're not drawing a graph. What I'm talking about is when you assign random digits to your groups and you describe them, you should describe it using the exact same number of digits. So like if I have a group of 50 people, let's even go like this. If I have a group of 30 students, okay, I'm going to, for instance, assign each student in this classroom a 2-digit number between 0, 1, and 30. I don't want to say 1 and 30 because when I use the random number table, I'm going to select 2 digits at a time. If I'm selecting 2 digits at a time and I assign someone the digit 4, it's never going to appear.
Okay, do we have to use that table every time?
Yes. I'm just going to say yes to that. Do you have to use it every single time? If the problem asks you to, yes. It says use table A. Or sorry, table D. You should be using it. Okay? So you should be following these guidelines here. Okay? So, one of the biggest favors you can do yourself is always use the shortest number of digits. Okay? So if I have, like my example of 30 students in class, I want to use 2-digit numbers. I don't want to use 3-digit numbers, because if I use a 3-digit number to assign to 30 students, okay, there are 30 numbers on the table that will actually be used to select the people, and 970 numbers that aren't possibilities. It might take you a long time to get your small sample. Okay. All right, so let's show you how you can approach one of these problems, and how you should. Okay. So in our example here, I'm going to move it up, but I'll pull it back down. It says the management company of a local mall plans to survey a random sample of 3 stores to determine the hours they would like to stay open during the holiday season. Use table D at line 101 to select a simple random sample of size 3. So this one specifically is telling you to use the random number table. It's telling you exactly where to start and how many to actually select. Now you have to tell me how you label them and how are you going to actually select them. Okay? And then you do it. So, to start us off here, so let me move this up just a little bit. I start with the label part. Okay? And the label part is usually just one sentence. I'm going to describe how I'm assigning the digits. So, assign each store, because that's what we're talking about, so it might be a person or an item or whatever it is. So we're going to assign each store a 2-digit number from 0, 1 to, well, how many stores do I actually have? Well, if I look at my list here, I have 1, 2, 3, 4, 5 by 4. 5 times 4. So from 0, 1 to 20, now I have to decide how am I going to assign them. Okay? Probably the easiest way I am assigning them, and I find the easiest description to use, but it's not the only one, is I'm going to say in alphabetical order. Do you always have to say alphabetical order? No. I could say, I could assign them going in columns from left to right. But you have to describe that to the reader. So when you do this, for instance, on an exam, I will look for how you describe this and follow it. And see, do I get exactly the same answer with the directions you give me? Okay? So I'm going to assign each store a 2-digit number from 0, 1 to 20 in alphabetical order. I'm going to do that right now. What's nice is, these are in alphabetical order, going in rows from left to right. Notice how I'm doing a 2-digit number, even for 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why 6 is afraid of 7, right? Now, we have to describe on the table how we're going to select our values and determine how we're going to get our 3 stores. So, using Table D, starting at line 101, we will select 2-digit numbers until the 3 stores. Well, actually, I don't want to say that yet. Sorry, I get ahead of myself sometimes on these. Well, that's why you can cross it out or erase it. Two-digit numbers from 0, 1 to 20. If the number repeats or is between, are we okay up back there?
Yeah.
21 and 00, we will ignore it. I'm sorry?
What's that last sentence? What is that? The number repeats.
If the number repeats or is between 21 and 00, we will ignore it because it doesn't represent one of our stores. Okay? And if it doesn't make sense quite yet, let me show it on the random number tail or on the random number digits. Do this process to select our 3 stores. So now what I'm going to do for you right now is I'm going to copy parts of line 101 here for you. So if hopefully I still have it here. Well, I had it at one time, maybe I closed it down, we'll see. Oh, is it going to download for me again? There we go. So what I'm going to do is put this up really high. It lets me scroll it. I get the spinning wheel of death usually. But at least it did. Because I just want to see where those numbers are coming from. So the first 5 random numbers are 19223. So I'm just writing these. So sometimes I have to step back to see the difference between the 5s and 6s. 95034. So they just put them in groups of 5. So 0, 5, 7, 5, 6. And then 2, 8, 7, 1, 3. I'll write one more. 9, 6, 4. So sometimes you have to write like 10 of these series. Sometimes this is enough. I hope this is enough. How do we know? Well, we'll go until I get my 3 stores selected. So according to my directions, I have to select a 2-digit number. All right? So my first 2-digit number here is 19. Is 19 one of my stores?
Yes.
Yeah. So I got 1 store selected. So I'm going to put a box around it. My next one is 22. Is that one of my numbers? No. So that's why if the number repeats, so if I were to get 19 again, I would ignore it. If I were to get a number between 21 and 00, I'm going to ignore it because it doesn't represent one of my stores.
But I thought all of our numbers are between 21 and 00.
No, the numbers that we have assigned are between 0, 1, and 20. Okay? So we've assigned the 20 stores that. Okay? So numbers 21 to 00 don't mean anything to us. So we want to make sure the reader understands that, all right, if I get a 24 when I'm selecting 2-digit numbers here, what do I do with that number? Now, you could have, I suppose, assigned, for instance, the first store the numbers 01 through 05. And then the second store 06 to 10. And so they each got 5 numbers. You could have done it that way.
Right.
So there's like more ways. I just want to make sure with this 2-digit number, each store or each number, I know what to do with. So now I'm going to go a little bit faster.
Why line 101? Are you always using that line, or like you just randomly chose that line?
I'm actually using that line only because the problem told me to use line 101.
Will the problem always tell us which line to use?
Yes. Yes and no. And the reason why I'm going to say no is if they don't tell you what line to start, what they'll do is they'll say, use the random number table below, and they'll give you a little section of it. And they'll just say, show your process down there. So you'd just be doing the same thing here. They gave me like a series of this many numbers and like 3 rows of it. I'd start in the upper left and just go across. So now, as I continue on, here's 39. Is that a store?
No.
How about 50?
No.
34?
No.
5?
Yes.
Yes, we got 2. 75?
No.
62? 87?
No. Yes. Yeah.
Good, I didn't have to do that last chunk of numbers. Because even 96 and 40, I wouldn't have had it. I would have had to get more numbers. So, the question becomes, what are those 3 stores? And that's what you want to state at the very end. So, Star Jewelers was selected. Carter's for Kids. There you go, Carter. You were selected. And 13, Mrs. Fields. Nice. Get some cookies. So, we'll just say the 3 stores selected are, the first one was Star Jewelers. That was Carter's for Kids. And Mrs. Fields. This, and probably when we outline an experimental design problem, is probably the most math that we will do in Chapter 4. If you even consider this math. There's actually numbers. Okay. You have to kind of think and break down, you know, you might have to break down like a percent into out of 100 and something.
I signed up for that class. This is outrageous.
Oh, is that 3, not 5?
We said 3, yep. So if I had to do this 5 times though,
There wouldn't be any.
you would have to write more numbers up here and continue the process until you got 5 of them.
We're all joining the coast guard.
Alright, so